Recently, silver prices have surged so rapidly that the world has started paying attention once again to the metal that was once seen as the cheaper version of gold. But what most people do not realize is that behind it lies an industry worth more than $40 billion every single year. So why has silver become one of the most important metals in the modern world? Let's find out in today's video. For most of human history, silver was actually more important to ordinary people than gold. More than 2,500 years ago, ancient civilizations such as Greece and Rome were already using silver coins to power trade, pay soldiers, and collect taxes on a massive scale. Then, in the 16th century, after Europeans arrived in the Americas, enormous silver mines in Mexico began operating on a scale the world had never seen before. And even today, Mexico remains the largest silver-producing country in the world. But perhaps the most fascinating chapter in silver's history came during World War II. When the United States faced a major copper shortage during the war, the U.S. government used more than 14,000 tons of silver from the National Reserve to build massive electromagnetic coils for the Manhattan Project, the program that developed the first atomic bomb in human history. But what makes silver truly valuable is not just its thousands of years of history, but also its incredibly unique physical properties. One of them is its electrical conductivity, the highest ever discovered by humans. Silver actually conducts electricity better than both copper and gold. That means electrons can move through silver more easily than through almost any other metal on Earth. That is why silver can be found inside smartphones, computers, military radar systems, satellites, and even massive AI data centers. But interestingly, most everyday electrical wiring does not use silver. The reason is simple: silver is too expensive. Copper is far cheaper and still performs well enough for most normal applications. But electrical conductivity is not the only strange thing about silver. Today, modern science shows that silver ions can damage enzymes and internal structures inside bacterial cells, making it difficult for them to survive normally. That is why silver is still used in many modern medical products today, including anti-infection wound dressings, antibacterial coatings in hospitals, water filtration systems, and even certain specialized medical devices. But silver still has another remarkable property that many people rarely think about: its incredible ability to reflect light. In fact, silver is the most reflective metal ever discovered by humans, capable of reflecting around 95% of visible light. That is why, for hundreds of years, people used silver to create some of the first high-quality mirrors long before aluminum became common. And silver's role does not stop with ordinary mirrors. This same property also makes it extremely useful in telescopes, optical equipment, and many high-precision light systems. What is fascinating is that even when the silver coating on these devices is thinner than a human hair, it can still reflect light more efficiently than almost any other metal on Earth. And it is these unique properties that have turned silver into one of the most important materials in modern industry. And perhaps the thing that worries many experts the most today is that the world is beginning to consume silver faster than it can mine it. Over the past few years, silver prices have continued to rise sharply. In 2024 alone, silver prices briefly climbed above $30 per ounce, the highest level in more than a decade. But the problem is that silver supply is not growing nearly as fast. Every year, the world consumes around 1.2 billion ounces of silver, while total global mine production is only about 850 million ounces. The remaining shortage must mostly be covered by recycling and existing silver reserves already available on the market. A metal that was once used to mint coins thousands of years ago is now hidden inside smartphones, satellites, solar panels, and nearly every modern electronic system on Earth. So how is silver actually made? Let's find out right now. In nature, silver rarely exists in a pure form. Instead, it is usually buried deep underground inside ores that also contain lead, copper, or zinc. At modern silver mines, the extraction process begins with massive underground tunnels carved through solid rock, using specialized industrial drilling machines. Once miners locate areas containing silver ore, large holes are drilled for explosives. These blasts are carefully calculated to break apart the surrounding rock while keeping the overall mine structure stable and safe. The fragmented ore is then loaded onto heavy-duty mining trucks and transported to conveyor systems or lift shafts that carry it up to the surface. From there, the ore moves into large industrial crushing facilities before entering the next stages of silver separation and refining. Once the silver ore reaches the surface, it enters the first crushing stage. This process is carried out by enormous industrial jaw crushers. Inside the machine are two ultra-hard steel plates that work like a giant mechanical jaw, continuously compressing and breaking the ore into smaller pieces. Automated sensors monitor crushing pressure, temperature, and machine load in real time to prevent the rock from being overcrushed and losing valuable minerals. After this stage, the ore is usually reduced to pieces around 1 to 4 inches in size. At modern mining operations, these crushing systems can process thousands of tons of ore every single hour. After the initial crushing stage, the silver ore moves into a fine grinding system to prepare for chemical metal separation. At the center of this process are massive industrial ball mills, giant steel cylinders filled with hundreds of ultra-hard metal balls. As the machine rotates continuously, the balls slam into the ore again and again, grinding the material down into a fine powder that looks almost like sand or sugar. The entire system is controlled almost completely automatically. Sensors constantly monitor rotation speed, water levels, and grinding pressure to make sure the material always reaches the correct size for the next stage of processing. Once the ore has been ground into a fine powder, the mixture moves into the flotation stage. The powdered ore is mixed with water inside massive industrial tanks, where special chemicals are added to make the silver-bearing particles attach to air bubbles instead of sinking in water. From the bottom of the tanks, millions of tiny air bubbles are continuously pumped upward. The silver particles stick to these bubbles and slowly rise to the surface, forming a thick layer of mineral foam on top. Automated skimming systems constantly collect this silver-rich foam and send it to the next processing stage. Meanwhile, heavier rock, dirt, and unwanted materials sink to the bottom and are removed from the system. After flotation, the recovered material still contains a large amount of water, so it must be concentrated further before refining. The mixture is pumped into enormous industrial settling tanks, where gravity slowly pulls the silver-bearing particles down to the bottom while the water above is collected and recycled back into the plant. After hours of continuous processing, the material at the bottom gradually turns into a thick silver-rich sludge with a much higher concentration than before. This concentrated slurry is then pumped into large storage tanks to prepare for the smelting and refining stages that come next. After leaving the flotation system, the silver-rich mineral sludge moves into the initial smelting stage. The material is loaded into industrial furnaces operating at temperatures above 1,800 degrees Fahrenheit. Inside the furnace, the extreme heat melts the mineral mixture and begins separating different metals from one another. Impurities such as lead and zinc gradually oxidize and rise to the surface as molten slag, while the heavier silver settles at the bottom. Sensors continuously monitor temperature and pressure inside the furnace to keep the metal separation process stable and efficient. Even after being melted down, the silver is still not pure enough for modern industrial use. That is why it must go through another stage called electrolytic refining. At refining facilities, the raw silver is placed inside enormous electrolysis tanks filled with special chemical solutions. As electric current flows through the system, Silver atoms slowly separate from the original metal block, dissolve into the liquid, and then crystallize again onto other metal plates with extremely high purity. Meanwhile, impurities such as copper, lead, and zinc remain behind at the bottom as metallic sludge. After many hours of continuous operation, the purified silver is collected, melted again, and cast into industrial silver bars with purity levels that can reach as high as 99.99%. Once the silver reaches the required purity level, the molten metal is poured into industrial steel molds to form finished silver bars. The bright white liquid silver flows continuously into the molds at extremely high temperatures before slowly cooling and solidifying into metal blocks, weighing around 60 pounds each. During this stage, temperature must be controlled very carefully to prevent surface cracks or air bubbles from forming inside the silver bars. The molds are usually coated with a special graphite layer to keep the metal from sticking as it cools and hardens. This is also the moment when silver officially transforms from raw underground ore into a fully formed industrial metal, ready to enter the global supply chain of the modern world. Silver may not be as expensive as gold, but its role in the modern world is far greater than most people realize. From smartphones and electric vehicles to solar panels and advanced technologies, silver is quietly helping power the daily lives of billions of people around the world. If you found this video interesting, let us know in the comments which use of silver surprised you the most. And don't forget to like, subscribe, and turn on notifications so you never miss our next stories about the ordinary things that are far more important than they seem. Thanks for watching, and we'll see you in the next video.